All right, today we're going to talk about measures of central tendency, which is mean, median, and mode. And we're going to talk about how to make a box and whisker plot. So this should all be review, but some of you guys never received any information on box and whisker plots. Okay, and what this all is part of statistics, a way to organize and study and analyze data. Okay, so there's three ways to talk about the middle of data, and it's the central tendency, which is mean, median, and mode. Okay, mean is average. Average, you guys know how to find the average of a set of data. These are all middles, the middle parts of a bunch of numbers, which is your data. So the middle value is found by adding up all your numbers and dividing by the number, how many you have. Okay, now there's another way to write mean. It's X bar. That means average. X bar means average. Median is the middle number. You have to physically organize these numbers from least to greatest. The middle number is the median. Now, what happens if there's an even number of data? You take the two middle ones and divide by 2, add them up and divide by 2, average them. Mode is the one that occurs most often. Sometimes two numbers will occur at the same time most often. If that happens, we say that that is bimodal data. Bimodal means there's two modes. Now, if there's more than two modes, if let's say three numbers occur more than, the same amount most often, then we say that the data is statistically unuseful to find the mode, okay? And if no number occurs most often, then if they all, let's say, occur once, then we say that there is no mode, okay? So all that you have here, I'm just going to go through this super quick. We have a frequency table, and what this table says is how many job offers a student gets within 2 months of graduating. So the way you read this is 2 students received 0 job offers. 2 students received 1 job offer. 4 students received 2 job offers. 5 students received 3 job offers, and 2 received 4 job offers. So if you were to stretch this out, you have 0, 0 twice, you have 1, 1 twice, you have 2, 2 4 times, 2, 2, 2 4 times, you have 3 5 times, and then you have 4 2 times. This is a frequency table. So to find the average, you would add these up and divide by however many you have, which is, there's 15. Okay, you count these are the number of students you have. There's 15 students here. Okay, so the average, which and notice how they wrote X bar, that's how you say it, X bar, that is the mean, the average. So when you see X bar equals, that's the average. The median is the middle number. So what if you looked at these 15, the middle score is 2. In the mode, the one that occurred most often is 3 job offers. So I just need to know, are you guys okay with mean, median, and mode? Mm-hmm. You guys are good? Okay, let's move on. What is an outlier? An outlier is a value that substantially stands out. It's different than all your other data. For example, yesterday, the seniors were gone, and in my classes, I normally have about 22 kids in a class, okay? But yesterday I had 2 students in some of my classes. So if I were looking at data day to day, the data on this day would probably be an outlier because I only have 2 students here. That's not normally what's going to happen. Another thing, like you could think of an outlier, is if you have a machine and it normally produces 100 widgets, hundreds of something, and So what on an average, it produces 100. So one day it produces 99, one day it produces 89, one day it produces 95, another day it produces 90, then 99 again, okay? And then at one day it produced 2. This would be called an outlier. Something must have happened. If we include this number in our data to figure out one of the measures of central tendency, the mean, median, mode, this is going to change our data. It's going to change our mean, it's going to change our median, it's going to change our mode. So what a lot of times we throw out any outliers. Now what may have happened is maybe the machine broke, or maybe it was a half day of work or something. But this is not a typical number of units that the machine would produce. So this was a fluke thing, in other words. So an outlier is very subjective because you want to look at your data and just make a decision. It's very subjective on what would be considered an outlier. Like for example, here's data, and it's organized. And how they figured out that 98 is an outlier is they looked at the differences of these, and they were all within, I don't know, 5, 10, 0 to 10. And then all of a sudden this one jumps to 25. So they call this one an outlier. Okay? So an outlier is a number that substantially differs from the highest or the lowest of your data set. Okay? All right, go down here to range. And now I'm going to show you how to organize data. Okay, let's look at this example right here, back here. They are comparing, here's a table, and it shows the average monthly water temperature for 4 different locations in the Gulf of Mexico. Now, one way to compare the 12 temperatures is to use, you can either, figure out mean, median, and mode. Okay? And another way is to create a box and whisker plot. How many have created box and whiskers before? How many people know what I'm talking about? Okay. I'm going to show you how to make a box and whisker plot for St. Petersburg, Florida, and for Key West, Florida. Okay, so here are all of the average temperatures, monthly temperatures from January to December. For St. Petersburg, in January, the temperature is 62 degrees, and in February, it's 64 and 68. So if you organized your data and ordered it from least to greatest, this is what you would get. Okay, so the lowest score is 62, and the highest score is 86. Now, if we were asked to find the average, which is x bar, the average, you'd add them up and divide by 12. So we don't need to spend time doing that. The average temperature is 75. We are not going to we don't have any outliers. They were all pretty close to each other, so we have no outliers. No outliers at all. The modes, what occurred most often are 64, 84, and 86. Now, I would consider this mode very unuseful because there's 3 of them. After 2, we say it's bimodal, but the best case scenario is having 1 mode. So this one has 3 modes. We're going to list them, but it's statistically, they say, unuseful. Okay, the middle number is 76. How do you find the middle number when there's even number? There's 12 of these. You take the 2 middle ones. Now, when I say middle, I don't mean the 2 middle months. I'm talking about taking your numbers and organizing them. You have to organize them from least to greatest. So these are all reorganized. 62 is the smallest, and 86 is the largest. Now, when we're talking about the range of data, the range is the biggest number, 86, minus the smallest number, 62. When you subtract those, what do you get?
24.
You get 24. So the lowest number is 62, the largest is 86. So it ranges from 24. The middle number the median in this data is 70, what? 76. And how do you get 76? You take the two middle ones and add them up and divide by 2 because there's an even number. This middle number is going to be called your second quartile. It's the second quartile. Now, what you've done is you've broken your data into two parts, the lower part and the upper part. What you're going to do is find the median of the